All right, let's dive into some of the oldest and most fascinating puzzles ever created, Zeno's paradoxes. Now, these aren't just quirky brain teasers. For over 2,000 years, they've seriously made people question the very nature of reality. So get ready to question everything you think you know about something as simple as motion. This is the big, mind-bending question at the heart of it all. I mean, it sounds crazy, right? Of course things move. But Zeno was a master at creating these elegant logical traps that make something so obvious feel, well, almost impossible to prove. So let's see if we can unpack this mystery.
So, we're going to start with Zeno's most famous paradox, sometimes called the dichotomy. It's the story of an incredibly fast runner, we'll call her Atalanta, who, according to Zeno's logic, might just be stuck in a race she can never, ever finish.
Okay, here's how the logic works. Before Atalanta can possibly get to the finish line, she has to run to the halfway point. Makes sense. But wait. After that, she has to cover half of the remaining distance, and then half of that new remainder, and then half of that, and on and on and on forever. You see the problem? Her journey gets split into this infinite series of smaller and smaller steps.
And this is the real kicker. If you have to do an infinite number of things, shouldn't it take an infinite amount of time? I mean, how can she ever complete an endless list of tasks? How does anything ever get from point A to point B? Zeno's logic makes it seem like all motion should be completely impossible.
Now, for a long, long time, this was a massive philosophical headache. But then, a few centuries ago, calculus came along and gave us what is now the standard textbook answer. Let's take a look at how modern math supposedly solves Zeno's impossible race. The magic trick here is a concept called a converging series. It's this really cool idea in math where you can actually add up an infinite number of things, but the total sum is, well, a totally normal finite number. The distances Atalanta runs, a half, then a quarter, then an eighth, they all form a series that adds up, or converges, to exactly 1, the full length of the race.
So here's the bottom line of the standard solution. Yeah, okay, there are an infinite number of steps. But, and this is the key, each of those steps takes less and less time to complete. So just as the distances add up to 1, the tiny little bits of time it takes to run them also add up to a finite total. Atalanta finishes the race. Problem solved. Case closed, right? Well, maybe not. What if that whole complex calculus solution, as elegant as it is actually a huge overcomplication? What if we've been trying to find a fancy answer to the wrong question, and in the process, we've completely missed a much simpler, more powerful truth that's been hiding there all along?
And this brings us to a really fascinating different take from a physicist named Mathis. He basically argues that we don't need calculus. We don't need any of it. The answer isn't buried in some complex math. It's staring us right in the face, hidden in plain sight, inside Zeno's original question. Mathis says the whole confusion comes from mixing up two totally different things: the time it takes to calculate something versus the time it takes to do something. Look, it would literally take you forever to sit down with a pencil and paper and add up every single number in that infinite series. But physically running those distances, that's not the same thing at all. Motion isn't a math problem. Atalanta's legs aren't performing addition. This quote from Mathis just nails it. He says the paradox is basically a trick. It's built on a hidden contradiction. You see, to even set up the problem in the first place, Zeno has to assume that Atalanta can move. He has to assume she can reach that first halfway point to even get the infinite series started. Just think about it for a second. Zeno says, to get to the end, you first have to get halfway. Mathis's brilliant response is, wait a minute. If she can get to the halfway point, she has already moved. The midpoint is just the end point of a shorter race. If covering that distance is no problem, then why should covering the full distance be? The entire paradox just falls apart the moment you look at the setup. Okay, now let's see how the same kind of critical thinking handles Zeno's other big paradox, the arrow. And this one's different. You can't just sum up a series to solve it. This one gets at something even deeper, the very nature of time. So here's the problem. Picture an arrow flying through the air. Now imagine you could freeze time and look at it at a single, indivisible instant. At that precise instant, the arrow isn't going anywhere. It's just there, occupying a specific chunk of space. It's frozen. So Zeno argues if time is just a long chain of these frozen instants, and the arrow isn't moving in any of them, then how does it ever move at all? And this is the billion-dollar question that Mathis wants us to ask.
I mean, we talk about an instant all the time, right? But does a frozen moment in time, one with absolutely zero duration, actually exist in the real physical world? Or is it just a made-up idea?
Mathis's answer is pretty direct. The whole idea of an instant, a point in time that has zero length, is purely a mathematical invention, an abstraction. It has no physical reality. You can't have a slice of time so thin that nothing happens because the very definition of time is change.
So the whole thing comes down to this. Motion, by its very definition, has to happen over an interval of time. It needs a start and a finish. I mean, velocity is distance divided by time. If the time is zero, the whole concept is meaningless. So talking about a moving arrow being stopped at an instant isn't a deep paradox. For Mathis, it's just a flat-out contradiction in terms.
And this all leads to a much bigger point. For Miles Mathis, the lesson from Zeno isn't just about solving some old Greek puzzles. It's a huge warning sign for how we think about science and math, even today.
I love this quote. In science, we often treat paradoxes like they're these cool, mind-bending clues to some deeper truth. Mathis completely disagrees. He says a paradox is like the check engine light on your car's dashboard. It's not something to admire. It's a bright red flag telling you that something in your fundamental logic is broken.
So from this point of view, when you run into a paradox, you shouldn't just accept it as a mystery. You should treat it as a signal that your starting assumptions are wrong, your definitions are messy, or that the question itself is flawed. Just like Zeno assuming motion to disprove motion. And he doesn't just stop with Zeno. He takes this exact same logic and applies it to some of the biggest, most famous ideas in modern science. Things like the twin paradox in Einstein's relativity or the wave-particle duality in quantum mechanics. He sees these not as profound truths, but as signs of unresolved errors in our thinking. It's a really bold stance, but it all comes from that one simple idea. A paradox is a symptom of a problem that needs fixing.
And ultimately what this does is it kind of redefines the whole point of logic and math. The goal isn't to create confusing intellectual puzzles. The goal is to use logic as a sharp tool to find and fix mistakes so we can build a clean, consistent, contradiction-free picture of how the world really works. Mathis even thinks this is Zeno's real goal all along, to teach his students by challenging them to find the hidden flaw in the argument.
So that leaves us with this final, really powerful question. When we encounter a paradox, are we getting a glimpse into a deeper, stranger reality than we ever imagined? Or are we just looking in a mirror that's reflecting a fundamental mistake in our own thinking? The way you answer that might just change how you look at everything.